We're at part 2 now, and it is the autonomic nervous system. We're looking at parasympathetic and sympathetic, and we're comparing it in this picture to the regular motor neurons that operate our skeletal muscles right here. Okay, so notice that this is also highly myelinated and very fast. These are also myelinated, at least up front here in the first order neuron, not so much here. Another detail that I need you to be aware of is that we are going to be dealing with acetylcholine, 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 acetylcholine. Okay? Over here we have norepinephrine or epinephrine. Here we're going to be having norepinephrine and epinephrine. Okay, in fact, I'm going to just say epinephrine from now on rather than make a distinction. Okay, so we have some epinephrine here, but notice that I'm using acetylcholine here, and I'm using acetylcholine here at all of the synapses having to do with the ganglion. Whenever we have to go to a second order neuron, and don't underestimate that this is not a neuron, even though it's just delivering epinephrine to the blood, it's still in essence a neuron, and it comes from the neural crest cells. Okay, so it has the distinction of working in the nervous system. It's an important detail. And what I'm noting here with the red arrow is that all of this is called, these are nicotinic receptors. Same molecule is going to bind to different kinds of receptors. Here's a nicotinic receptor, here's a nicotinic receptor, here's a nicotinic receptor, here's a nicotinic receptor. Okay, over here, this is not a nicotinic receptor. Okay, this is a muscarinic receptor. Now, if this reminds you of tobacco, you're correct. Same nicotine. Okay, if this reminds you of magic mushrooms, you are correct. Muscarine is a molecule found in Amanita mushrooms, right? So, and so there's a distinction here between what it does and how it does it. So these particular receptors are able to be affected by muscarine. These particular receptors can be affected by nicotine right here. Do you think nicotine is possibly an addictive drug? If you think so, you would be correct. Nicotine is a highly addictive drug. Okay, and it deals with us in a very deep area of our anatomy and physiology. So I would recommend that you you avoid the opportunity to dose yourself. It's when you're using something that interacts with receptors, like opiates, for instance, would heroin be addictive? And the answer is yes, it would be addictive. The idea here is that anytime you're able to bind a receptor in the human body by exogenous means, then you're doing something that requires the exogeny. Okay, when the body needs to do something of its own, how shall I say, arrangement, I would call it endogeny. So try to be as endogenous as possible. That doesn't stop some of us from being distance runners because it feels good. Some people are, how shall I say, some people can be adrenaline junkies because they enjoy this part of the physiology. Okay, so the activity there could be considered a kind of exogeny. So be careful. Jumping out of airplanes and stuff all the time could have some consequences. Running more than 15 miles a day every day back to back for too many how shall I say, weeks, months, or years can have its effect as well. So be gentle with yourself whenever possible and consider balance. Okay, then, so with this in mind, we'll come back to this from time to time. And now we're going to compare some other aspects, the anatomy and morphology of the parasympathetic, which is represented here in the purple color, and the sympathetic, which is represented here in the green color. So, and here are all the target organs. And so these are the arrangements that are being made to arrive at the target organs. As you can see, when you only are using 4 cranial nerves, some of those nerves have to be extraordinarily long in order to get to the target organ. And in fact, notice that the ganglion in the parasympathetic system is actually in the target organ. Isn't that interesting? Or near it, very close to it. Okay, so this is right on the surface of the eye right here, this particular unit. And so you have to, there was, by the way, there were out of 232 students in my class in medical school, 2 of them were able to dissect and find that particular ganglion out of 232. And guess who are going to become surgeons? Okay, those 2 people were at least on the pathway. Okay, then, and we're going to be finding other types of things that will work this way. Okay, so this is the parasympathetic system. It's hardwired. It has to be hardwired. We don't have a system, a hormonal system, that does quite the same thing as the hardwired parasympathetic system. Okay, down here we have the sacral outflow, and again we have a relatively long first order neuron which goes into the walls of the organ of interest here, and it synapses with its second order neuron cell body, which doesn't have to travel very far to engage in its activities. Okay, whereas we have a slightly different arrangement here with the sympathetic nervous system. We start at T1 to L2. We're in the gray matter of those, that part of the spinal cord, okay, in the lateral horn. That's the location, in the lateral horn, gray matter of the spinal cord, T1 to L2. And then we're going to look very carefully, we're going to look at the anatomy of how the spinal nerve has its transmission and how it's going to arrange itself with the sympathetic trunk. In some cases, we'll go to the sympathetic trunk and then we'll synapse, like right here, we'll synapse, and then we'll continue on with the spinal nerve and go to the stomach or go to the pancreas. In some cases, we need to get to the eye in order to dilate our pupils, for instance. And so instead of synapsing here, we'll come up through the neck region and we'll synapse up here. And then we'll be able to get to the eye. Okay, so these are some individual issues that we'll have to cope with. Notice also that the second order neuron here is in a lighter green color, sort of a minty color. And in some cases, the first order neuron goes a long ways. So we go all the way to the adrenal gland before we find the next cell. And they don't even represent it in the light green color. Okay, so the adrenal gland, or in this case the adrenal medulla, is going to be the location where the cells that produce epinephrine and norepinephrine that enter the blood, that's where we're going to have this. So we have this first order neuron that goes all the way across there. So anticipate that. Then we're going to come to this next page, and here's the big overview then for the sympathetic nervous system, and we're going to have to go slowly through here and track the cranial outflow, which is cranial nerves 3, 7, 9, and 10. Okay, and then also the spinal nerves S2, 3, and 4, with the pelvic splanchnic nerves coming out this way. So we're going to go slowly here. There's a lot of morphology, a lot of getting used to this, because it's not something that we normally think about or look at in daily life. Okay, but it's extremely essential that we have this experience. Okay, I also want you to be aware of when we say parasympathetic tone and nervous system, when do we have our best parasympathetic tone, when is it really fully most on, in essence, is when we are completely at rest or actually asleep, in some stage of sleep. Okay, so keep that in mind as well, and then we'll come to part 3.